Okay, I think we'll start. Right.
Yeah.
So good afternoon, everyone. On behalf of the Indian Society of International Society of Photogrammetry and Remote Sensing, ISPRS, Indian Society of Remote Sensing, and NISAC, I welcome Professor Saeid Pirasteh and all participants to this second and very important lecture as part of the ISPRS Working Group 5.4 webinar series. We also have Dr. SP Aggarwal, President of the Indian Society of Remote Sensing and also Chair of the ISPRS Working Group 4 in Technical Commission 5 and Director of NISAC with us. And I welcome you, sir, also. Our deepest gratitude to Professor Saeid for accepting to our invitation and also for being generous to a couple of times of date changes. So I think before I start, I'll like to take a couple of minutes to introduce Professor Saeid to the audience. It's really a pleasure to introduce you, sir, to the audience. So Professor Adam Saeid Pirasteh is now working as a Geometrics and Geospatial Artificial Intelligence Professor and the Associate Dean at the Institute of Artificial Intelligence at Shaoxing University in China. He's the co-founder of Shaoxing Institute of Artificial Intelligence. And in addition, he's a visiting professor and senior scientist at the University of Waterloo, Canada. He received his first PhD degree in remote sensing and GIS from Aligarh Muslim University in India in 2004, and also received another PhD degree in geometrics and GeoAI from the University of Waterloo in 2018. He's also the chair of the Canadian Institute of Geometrics Overseas Network. He is currently an expert and member and executive committee member of the United Nations Global Geospatial Information System Academic Network and IEEE senior member, as well as chair of the ISPRS Intercommission Working Group 3 and 4A. And I'm happy to share here that working group of our working group and his working group, we are jointly hosting a workshop in the upcoming Geospatial Week in Dubai. So Sir has 24 years of experience in research, development, teaching, administration, management, leadership, social engagement, and supervision at various universities and industries in various countries. His research interests include geospatial data science and GeoAI, remote sensing, computer vision, using satellite, drone, and LiDAR data and data processing, GIS and geospatial information analysis and modeling, and developing algorithms for their novel applications in hazards and disaster and beyond. His research direction is to advance scientific practices and innovations for sustainable and climate smart operations, particularly in the context of environmental monitoring and disaster management. He is the inventor and co-founder of the Geospatial Infrastructure Management Ecosystem, GeoIME, on which he will be delivering his talk today, and currently is seeking help commercializing his technology, product, and software. So he has co-authored over 300 publications, including top journal publications, and is also this associate editor of IEEE Transactions on Geoscience and Remote Sensing, an associate editor and IEEE of IEEE JA Stars. He is also the editor of journals like Sensors, Remote Sensing, Natural Hazard Research, Geo-Environmental Disaster, etc. He has supervised and co-supervised nearly 100 masters and PhD students, postdoc fellows, and visiting scholars from various countries. And he has been honored with numerous local and international projects, as well as prestigious awards, including recognition from renowned organizations such as IEEE, ISPRS, FIG, and the Science Feather Awards. Notably, he was also bestowed with the Life-Saving Solution of the Year Award for the 2022 Expo in Miami, USA. So, sir, it's truly an honor and pleasure to have you delivering this talk today. And I'm sure all the participants will be immensely benefited from this talk. Over to you, sir.
Thank you very much, Dr. Kundu, and I really appreciate Professor Aggarwal and also everyone here, and the ISPRS, including the organizer, participant, all presenters, and everybody can contribute to us in this very safe word. Actually, we are trying to make it happen. So getting started actually with this presentation, perhaps I would say, if you have any question here after the presentation, you can ask friendly questions, or if you do not, then you can keep writing in the chat box. So I will try to answer all the questions accordingly. Thank you very much once again. And let me start with this presentation. And perhaps some questions in your mind if you have. So what is a geospatial infrastructure management ecosystem? If you know and you're aware about, so many actually systems in the current era we can have and we can see, including AIs, integrating systems, but also system to system. But now we are talking about ecosystem. So I'm going to talk about GeoIME in this regard, mainly focusing on determining building vulnerability and risk estimation. Before getting started, I would like to have you this video short clip. Can you see?
Yeah,
Yes,
we
yes.
can see your video, but if sound is there, we cannot hear it.
Do you have sound?
No.
Oh, I see.
Professor Saeed, since sound is not there, even you can tell something about this so that we can understand.
Yeah, okay. So perhaps in most of the countries, they are seismic. There are so many earthquakes happen in the world. And do you think that how many buildings really, let's say, for example, in a country or wherever you are, how many buildings are resistant against earthquakes? So we have buildings like residentials, commercials, hospitals, airports, and so on. So how to calculate, before an earthquake and after the earthquake, I would say the vulnerability of that building. So what should be done in that regard? So here we are talking about monitoring safety infrastructures, which is a significant actually means of resilience environment, and protecting people's safety and reducing property loss actually. So some of the country may have challenges in determining pre and post earthquake vulnerability and risk estimation of the building. So here I'm going to present the GeoIME application for a spatial data infrastructure to support monitoring, loss reduction, mitigation, and resilience in earthquake disasters. The base on this system is FEMA, which is a Federal Emergency Management Agency. So I would say 154 code actually. So everything is relying on that. So today, no doubt, I'm here to exchange my knowledge, and I can learn also from you with your comments, suggestions, how to make this GeoIME more stronger. Recently, we are working on actually GeoGPT. So that GeoGPT will get AI in its system. So let's put it, where is my actually a story starts with. Perhaps you remember in 2001, there was an earthquake in Iran. I'm basically from Iran originally, but I live in Canada. And now I'm in China, even though. So more than 70,000 people, they die. So after that, I get started, how could I actually save the lives of people? So in 2014, I established a concrete and test rehabilitation building earthquakes. So I talked to the government that time. So we started to build up a code, and then we screen all buildings. Most of the buildings were against the earthquake and more potential actually to damage or collapse. So that was the story. Then I get a PhD student in structural engineer. I'm not a structural engineer, but I got a PhD structural engineer. So we combine all things together. So the question comes with mind is as this one: what is the amount of building damage and how we can calculate actually the collapse of buildings before the earthquake and after the earthquakes? So, and how could I use the AI or geospatial power in that regard to save the money of the government and also the people, to prepare the people actually to save a life of people and make more awareness. Now, hopefully there are social medias and everything, we can do that. So moving forward, as I said at the beginning, do you think how many buildings you have in your countries? Hospitals, airports, schools. Like in China, we have more than 600 million buildings. So which one really is close to damage or collapse? And which one is more stronger? What should we do after knowing that that building, for example, is, you know what, potential to collapse? What are the reinforcement? What are the rehabilitation strategies we may take on? So these are the questions I'm going to answer. And practically at the end, we are going to have a very good tour on my website, GeoIME, which is a cloud base. So everybody can use a username, password, and determine their own buildings actually. So coming to this question again, do you think why in Haitian earthquake, 11% chicken died people, but in Chile only 1% with the same magnitude? What was the main reason? Well, somebody can say, you know what? The thing is that they were prepared. But it's not only that regard of preparation. It's also because of the awareness of the people, the government bodies. They could have a very nice strategy, making more rehabilitations. So consider now the countries, mostly the developing countries, they have even no, earthquake codes. Like in China, they don't have actually, or many other countries. I know India, they might have, but they do have a local one also. But in the US, in Canada, we use FEMA actually. So then consider other earthquakes like Haiti, as I said, 230 people, like 1,000 people that actually they died or maybe affected. So in Indonesia as well, in India, in China, and so many other countries. So coming to the challenges and how we can have covered and cope up with those challenges, only we should have a new innovation to solve the problems. Before getting to that, we have to understand what are the existing methods actually, and what are the challenges. So I like to have give some example regarding the challenges. For example, when it comes to the privacy of data, nobody is going to give you the data to screen the building. Let's say, for example, I'm going to Aggarwal, Professor Aggarwal's home. Do you want me to screen your building inside or outside? No. And who are the funders? Nobody. So the government, the private sectors, rarely they do that. So the pain point is actually on long time building assessment. The people, when they go to have a screen, they may take a long time on that. So to collect the data. So mostly it's cost effective as well. So to my understanding, for example, in Canada, in the States, they do have around $1,100 for 7,400 square feet. So it may take around a day or half day to go inside, outside of the building. So again, they do have the hard copies, they have to bring the form inside of building or outside of the building and to see visual screening. That's called rapid visual screening. So that kind of rapid visual screening, they type it on the form and take it to the lab, then analyze everything. It takes again a long time. So hard accessibility of information, sometimes the mistakes, because as for FEMA, for example, is around 400 pages. So who can remember really one after one? So that's why we code everything in 400 pages. We coded, mathematically everything come to the system. So the system, if you do any mistake, the system will let you know what, there is some mistake, you cannot go ahead. So then collection of data, validations, and so on. So we do not have online mapping, while here now I'm going to show you. So there are some existing methods I'm going to show you. But before that, let me share this slide with you. What is geospatial infrastructure management? It is actually an application on the web and also your phone, like a app, aiming at resiliency to strengthen the building infrastructures for pre and post earthquake. You can use your own phone to calculate your building. The vulnerability of your building, but it does not need research really to be an engineer professional. Rather, if you have just 20 to 30 minutes, of understanding class of geospatial and how does it work, that should be fine. Then later on, the system allows you to share your input with the professional engineer to approve that. That is one of the funny things in that system. Actually, I can share my data with any professional engineer nearby me. So, but let me tell you this for the FEMA. The FEMA has two actually approaches to screen or investigate the building. One is outside of the building, and another that's called level 1, and another one is level 2, which is inside the building. So that's why it's like visual screening, rapid visual screening with the shortest time. So what we do here, the main objective is to determine the vulnerability of infrastructures, or like building, for example, pre and post earthquake, and estimate of the risk of that collapse against an earthquake, forbidden God, if anything happened. So we came with this solution to have the geospatial information manage your job online and also doing it on the web. So in that way, perhaps if everybody does, which is a very nice actually participation of the people rather than only a professional, that is one of the biggest, I think, benefits of engaging the people in this assessment. So which is the SDG 17 actually, for more collaboration. So we save the life of people and also lose reduction. So as I talk about the FEMA, and maybe in India or somewhere else, and perhaps they do have some strategies to screen the building. So we're getting started to perform pre-field planning. Then they do have the form. They do have actually the call. Then somebody will go to perform field screening. Then after that, you bring the form to check the quality of the screening data and do analysis, and lastly do the results available of authorities. Then the results will be given to the structural engineer. So that is based on the recommendation of that particular person or investigator. So what happened is that the engineer, the structural engineer, would think about that, would come up with a nice strategy to how to reinforce the building, how to rehabilitate the buildings. That's not the job of the system. Rather, we only provide recommendations. What kind of the recommendation? In the next slide, you would be seeing that recommendation. So as I said about the existing methods. Now, let's say, for example, HAZUS is one of them, but it does not actually screen the building. It's only giving you the geospatial locations and so on. Rather, in FEMA ATC-20 rover, they give you an application, install it on your phone or your PC, personal computer. So you do have some exercises, and online you just fill up the form. So, but it does not calculate for you again. It does not give you the location. It's not geospatial based, right? And it doesn't have AI in it. Let's say, for example, image processing and so on. In China, they do have some. When I came here in 2019, I suggested them. Hopefully, they made it something similar, but not really the one I was thinking. That was one of the limitation for me, as I told you. When you're talking about the privacy of data and so on, of course, I'm an international here, so they have more concerns about that. So moving forward, we have to understand very well that the GeoIME technology system follows only FEMA 154 instruction code. Okay, but the good thing in this system is that we have customized, we have the ability of customization, and the scalability is good. It's very nice. If I give you the code, if I API, so you can run it in your home country and based on your local or governmental instruction code for that particular region, because region to region is different, right? But here we focus on FEMA. And mostly I look at FEMA when I see 400 pages. I read one by one words. So I think FEMA is more, I would comprehensive than other countries. And even though most of the countries, they don't have it, as I said. So at the beginning, I told you about my PhD student, how we started. So when I talked to my PhD student, I told him, listen, we need to come up with an algorithm, a novel algorithms to calculate the damage index. So this is this one is the damage index, actually, vulnerability estimation risk. So I have not idea much about this because I'm not a structural engineer. But if you have any question later on, as much as I can help you in that. So mostly we have the GeoEngine. So that GeoEngine at the back end of the system, you will not see. I make it very user friendly for everybody. You can use it. You will see the website and application very near seconds very soon. So what we do building investigate vulnerability risk prioritization, building scores, and you can also generate maps and report automatically and also intelligently. So the back end of the system come up with this framework. So at the left side, we do have actually type of disaster. What type of disaster you have? By the way, it's this kind of website, or I would say the technique on the application. It's not only about the earthquakes, because it's an ecosystem. What does mean by ecosystem? Means that you do have different kind of, I would say, hazards or disasters. From another side, you do have also different kind of infrastructures, roads, bridges, buildings, right? So, and based on the customization you might have, then you can have the instruction code of, for example, flood. How instruction code flood applies on the building for damage, for collapse, or road or bridges. So these are connected to each other. So everything is connected here. So what I mean to say that if you do have the API of this system, so definitely you can customize it based on flood, based on landslides, or based on, for example, any kind of infrastructure. In a state of building, you can do it for bridges. But I do not have the instruction code of bridge, for example. But if you do have, we can. So here only we are talking about the buildings, earthquakes. So we developed the earthquake structure algorithm, topology, connecting everything to each other, say open data. Then we use OpenAI, and then then we use, of course, servers. Then GeoAI develop algorithms for object change detection, image processing, recognition. For example, recently we have a module on crack detections. So simply I ask, for example, Dr. Kundu, send me your picture, the picture of your home outside or inside. So I've uploaded on my system. It gives me the crack percentage, which is the parameter of one of the, to calculate the damage of that particular buildings. There are so many parameters to calculate. I'm going to heading to that one very soon. So at the right side, you have field investigation for post-disasters also. So here is the GeoIME architecture in overall, actually. So from the user goes to web browser, goes to the type of disasters. So based on the type of disaster, you will select, you will know what instruction code, for example, you wanted to use it. So we do have a web server, we do have geo server, we do have GIS server, we do have database servers, and also, as you can see here, Google, mostly Esri. Thanks Esri, actually, very much. They help us a lot. Thanks Google also as well. They provide us good data. So what happened in the pre-post earthquake vulnerability and risk estimation? You can produce maps, report, 3D, real, and virtual visualization, street view, and so on. It depends on you, actually. You can have the modules on that and tools. So coming to the GeoIME features and tools. So mostly what we do in GeoIME features, we do have multi-purpose tools like combined GIS layers. You will see very soon the different kind of layers you can have added at the top of that. And now we are working on allowing people to upload their own data on that system. So we do have also, a statistical for probabilistic and deterministic computations. Easy, you can do that one. Let's say, for example, in your, let's say New Delhi. In New Delhi, you want to see that in Barakambara Road, for example, in that area, how many buildings are in potential to collapse. So simply you draw a polygon. So that will give you how many buildings would be collapsed. But there should be data before that. There should be some analysis before that, so which I'm going to show you later on. So we do have potential of image processing and feature extraction, as I told you, for example, crack detection using RCNN. We do have also support calculation of different level and scales. Then we incorporate uncertainty from the screeners. So if you go there and I go there, of course, because this is based on expert knowledge, visualization, there might be different things, right? So that's a different, but here in the system, the dot that do not allow you, it does not allow you to do some mistake or differences between the expert opinion, actually. So runs in the web and potential develop. You can have it on your smartphone. Potential for open source with quality assurance and testing. Complete the permanently database, updated information, and also free collaborative participation. Everybody can participate in that, either telling stories or many other things. So what does at the right side, we do have monitoring. You can do monitoring, mapping, visualizing, screening, and also you can do risk category, statistical analysis, data sharing, and finally recommendation. So these are the productive, the deliverable products. And as you can see, the maps, the 3D models, and also statistical. At the bottom right, if you can see real-time ground motion vibration, which I am really excited if we could have, some sensors. I did it in China. I purchased, I remember, around 3/4, vibration system sensors, ground motion. So what happened is that they send us the real-time ground motion, so you can monitor that particular building. Then automatically they send it to my system. But it didn't go through. As I told you, in China, it's very private. I mean, privacy also is there. So as an international, I said, I have to keep quiet. I have to step down on that. So, but this is the idea we are working on. So if you can see here, for example, you can see the, at the right side, top, the classes of the clustering of the buildings based on the color. For example, red is very much in potential to damage or to collapse. Then you can have at the left side, a statistical analysis, street video, and also at the right side, you do have automatic production of the report or recommendation, I would say. So this is the United Nations. I did have that exercise over there. So let's say, for example, here on the satellite image Google, so we have the pre-earthquake risk estimation report online. So at the end, by moving the cursor easily on each building, you can find it, or you can generate maps. So I'm going to show you in the couple of minutes. So this is after the earthquake. So what happened is that if you want to do post-earthquake assessment, right? So what would be happen? What is the existing method now? If an earthquake, forbidden God, happened, so what will be happen? The people, they say, okay, you know what? Go to the field and check each building, which one is really good, which one is not, and which one is more collapsed or estimated, to collapse. Whether can we use can we change the land use, for example, right? These are the strategies mostly the structural engineers they do. I'm not sure whether someone here has a background of a structural engineer or not, but we can talk later if you can help me as well. So what happened? They go to the field, they check if the building is okay. They put this tag at the left side. Inspected, put the tag. So what happened? The government or anybody in the future, when they come, they know that this is. Unless the relief of that particular disaster occur, remove, then come back to the resilience that particular time, then it's good. At the right side, for example, they put this tag. They have also red tag, which means that you cannot use that building, or should be demolished, or should be, for example, not used at all. So particularly, this is, as I said, this is the strategy of that structural engineer. So you will have the map like this one. You can also, synchronize it with the Google Earth and bring all your data, input, export, import. You do have this quality as well. So here is the website, GeoIME.ca. This is my startup in Canada. So I'm going to do that one, and right now, after the presentation, at least for a couple of minutes, maybe 10-20 minutes, I'll have a tour on that one to have more ideas of what exactly the website is about. But as a closure, to make it, conclude, I would say GeoIME, is mostly toward to giving you awareness, and that awareness perhaps can help you to resilient community and empower the government and non-governmental agencies, and then apply multiple organization. It can work with millions of people and also collaborate together. Seamlessly data you would have to evaluate that particular building, whether it is before or after that. The GeoIME can apply various scales from local communities to region and to also to the nationwide. Strengthen the rapid visual screening, RVS, problem solving, determine the vulnerability and estimate the risk of a building, and also data sharing. So that's the good things, actually, engagement of the people. We must have everybody to collaborate with that, to engage, to make more our environment more safe, actually. So as Professor Kundu at the beginning of introduction, he said about the awards. So that award actually was received in 2022 in Miami, and that startup company was among, I think, 300 plus companies. They were there, and I was one of the winners, actually, 3 winners, and I was one of the finalists one. And thank you very much for this presentation. Thanks to Esri, thanks to USGS, and also Google and everybody, my team. They work, very hard. We do have around 12 to 15 people work on that. Especially nowadays, we work on AI. As I told you, I call it. Let me call it GPT. So map GPT existed, but GeoGPT, I think this is the first time I'm using it. So that's why we are working on that. Now let's go back, do something practical. So these are the theory. I know so many questions perhaps you have in your mind, but let me come with the websites and do some models. Hold on. Some real words exercises. I don't know how to remove this. I just put it down. Maybe it's okay. So if you go to this website, this is an application. Okay, but easy. Can I go for 2 now? How much time do I have, Professor Dr. Kanda?
Yeah, you have at least 15 minutes. No problem.
Okay. So here, if you go to the website GeoIME.ca, I'm just coming above, actually, theory parts to make more elaboration on understanding. So if you go to GeoIME, so you will be able to do some practical activities, actually. So we are a startup, actually. After that idea came, I make a startup risk assessment software company. Just simply go to get it started. If you go to get it started, so it takes you to here, right? It takes you to here, but you should have actually your own username password. If you create your username password, even right away, I receive an email. So I'll give you, I can provide you the activation code. So based on that activation code, you will be able to do your own project. But here, as you can see, these are all my projects, but these are not real projects. These are testing projects, because still I'm in the testing, process, how much really the performance would be. So maybe by next year or next couple of years, that would be completed. Especially, we are working on GeoGPT. So at the right side, if you can see, there are layers of actually GIS. As I told you, so many layers you can have. And nowadays, I ask my colleagues, my developers, to allow people to add their own, actually, layers to get the analysis, because I understand most of the countries, they do have their own data, so they want to use it privately, so that's fine. So let's go, for example, for soil. If you go to the soil and I right click here, so as soon as I right click here, can you see, right? Can you see, right?
Yes, we are seeing it.
So if you click here at the right side, for example, show layers, then it gives you the soil type layers. Why soil type layers? Why they are the layers here, right? There are so many layers. And you can have additional layers here based on your own projects. Why did I put this one here? The reason is because when you want to calculate the vulnerability of the buildings, there are few parameters in that particular form based on your own country. But here I'm talking about FEMA. One of them, it asks you, one of the parameters in the system, in the form, it asks you, okay, where your building is about, what is the foundation, what soil type is it, right? So that's one of the parameters to impact your assessment. So here, easy, simply, if you right click again here, just on it, if you right click here, if you hit the bottom here, so it gives you the data automatically here. We are receiving on APIs from USGS, and thanks USGS indeed. So here it gives you, for example, the soil type of that particular region for that particular building is dense soil. What is dense soil? It's calculated by FEMA. If you go to 400 pages, you will find it. But that's why I said most of the people there, when the human work, they do mistake. But here it's not possible, because this one then so automatically, as soon as you click, it goes to attach with the form, right? So that's no mistake at all. So anywhere you can do that one, right? Now, for land, but again, another question is that why I use landslide? The landslide, again, landslide is one of the parameters to calculate the risk estimation and vulnerability of the building, right? That's why, again, if you right click here, if you're on the layer, you will find it, then it gives you the landslide map. So the landslide map, as soon as you hit it, it goes back you to the form, and it attached with the form. For the other layers also is the same, similar. But here there are not layers, actually. I did not put the layers, as I told you, because of the safety. But you can have your own, especially if you have the cadastral map layer. So it's very simple then. With the, if, let's say, for example, you have a shapefile, right? The shapefile in vector, easy to put it here in the system. Then you can connect it to the instruction code, which I'm going to show you at the left side here. So these are the data. So as you go back, you can have also satellite image, as every, perhaps you know very well this one, every application they do. You have a 3D model and some other features as well. But let's go back to here. I just go to the map. At the left side, as you can see here, hold on. As you can see here at the left side, there are some other features, profile, right? You can, after signing in, you can have your own profile, building information, my buildings, and so on, So the good thing is that because we have a short of time, I'm just going to have one of the example previous buildings we assessed for the United Nations. So I'm going to do that one here, perhaps. That would be much better. But if you like, if you have time, then perhaps I can draw your own building or my building where I am, so you know a step by step how to do it. So these are the database of all buildings. So simply here, of course, at the left side bar top, you can have the statistical analysis, right? As I showed you here. So, but you have to select your own region. So here, if you, let me type, for example, UN, okay, UN headquarter. So immediately it brings for me the UN headquarter. So it gives you, okay, at the left side here, green bar, you can see, okay, do you want to see the pre-earthquake evaluation, post-earthquake evaluation, or damage index? As if you remember, I mentioned the FEMA code, instruction code, that you have two levels, level 1, level 2. Level 1 is pre-earthquake evaluation, level 2 is post-earthquake evaluation. And damage index is for my PhD student. I showed you the algorithm. So let's go for the pre-earthquake evaluation. But before that, I'll just give you some features here. This is for editing, delete, And also the good thing here, you can share it with your friends, with your professional engineers. Let's say, for example, I am not a professional engineer, but still I did it. I'm in the evaluation. I am not sure whether this is right or wrong. So what I'm going to do, I just, after calculating everything, I share this one with my friend. So send to my screener. Who is your screener? The system will tell you who is nearby you. But here I did not put it, but we can actually do that one. Easy, we can do that one if you have the database of the people, so we can have it here. So going back again, so to UN headquarters. Let's do the first pre-earthquake. For the pre-earthquake, so here, if you can see, it gives you the data in 2021. I did this evaluation, right? As you can see, level 1, level 2, right? I did both. So if you hit here, okay, level 1, so hit it. So these are the parameters I was talking about, right? So above grades means how many floor is it, how many below grade, how many level below. So cutoff is always 2, the score based on the FEMA instruction. So you can select again which year. These are based on the instruction code. It's not me actually. So therefore, the other parameters like adjacency, if you can see here, so the adjacency, so you should have, if we do have a structural engineer people here, so perhaps they know what is it. So adjacency pounding and blah, 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 blah. Then after that, you do have occupancy. So this is the office, this is what? This is all based on the FEMA instruction 154 code. So then you do have exterior falling hazard. What is exterior falling hazard? For example, I have a building here, right? And my building, do I have another taller building than me? So if I do have, so what will be happen? So if the earthquake occurs, so perhaps if this building collapse comes at this building, right? So that's why it's more danger. So we have to understand that one as well. So you have a plan irregularity. So plan irregularity, you can have this one. So that's why how I said this is user friendly. I am not a structural engineer, but at least I can see the picture at the right side. What type of building mine is actually similar to this or not, right? Then I can hit that one. So after that, you do have also vertical irregularity. So for vertical irregularity, again, the same thing. These are the parameters for rapid visual screening level 1. So the people, they go inside the building and do it. They go in the field, they do it, right? But here we can do that one here. So there are other parameters here. As you can see, you can also upload your video, you can upload your image. The system can automatically actually do the image processing to extract some features, some information, and those information will be attached with that particular form. So after doing this, simply you can have your own, what do you call the recommendation form, right? So these are the one. So we calculated, right? 4.2. So as much as if close to 2, based on the FEMA code, close to 2 is more danger, is more potential to collapse. Above that, now you can see this is more good. So if I go for level 2, for example, in level 2, again, there are so many parameters here. There are so many parameters. I'm going to take to that one as well. But again, you can print it here, right? So this one goes to the structural engineer for recommendation. So if I go down, so here you can see, for example, this building. So as you can go, so simply you will see the scale, or I could say the classification or clustering map of vulnerability. So let me close this one again. Just going to level 2. I'm trying to for level 2, then I finish it. Level 2 headquarter, sorry, United Nations headquarter. So this time I'm going to level 2. Level 2, which is post, sorry, for the post earthquake. Level 1 and level 2 was for pre-earthquake, but here is the post earthquake. So again, you do have that one as well, right? If we go here, for example, for the post earthquake, you go the evaluation, even if you can the image, send somebody send you the image, the picture, the video, you can do. So you cannot need really to go to the field or save time. So there you will have some parameters again. So again, you print it here. So then print it here and tag it to your building. That's about the GeoIME. Actually, there are so many other things, but I know we have the shortage of time. And I know there are so many questions in your head, and let me to to have your question, and then for the simple way, I would do like this way perhaps. Okay, this is the theory part covered. The practical one from the previous studies you could see here now. Now, how about now if you want to do it right away, if you have a username password now, so how do you want to do it for your own building? Let's say, for example, this is a building, right? So if this is a building, let's say, for example, this is the building. So here, if you want to start from the beginning, if you want to start, then easily you can right click, you create the new building. So once you create the new building, you start editing. So draw your own building, right? Once you draw all building, finish. When you finish, then start your name, then start with your information. And meanwhile, if there are some information or data, I would say data, if there are some data available in your system and your database, so automatically will pop up here. So you don't need to type it. Let's say, for example, if you have a cadastral map at the right side, remember I told you at the right side, there are GIS layers. So there was a cadastral map. If you do have a cadastral map there, then connected with this. That's why here, once you connect it, you don't need actually to type all of them. So automatically will come up. Let's say I put, for example, building one address, let's say India, right? Okay, then save it. Once I save it, I go here, then I can start, like I can start pre-building evaluation, right? Are you sure you want to do this? Yes. Then start. What is the soil type? And so many parameters, as you could see in my practical, what do you call exercise for the United Nations? We did so many parameters. So you get started with that. With this, I appreciate all of you. Thank you very much. And if you have any question, please let me know. Thank you.
Yeah, thank you, Professor Pirasteh, for this very informative and elaborative talk with theory and practical. So there are already a few questions in the Q&A section. Do you see those, or you want me to read out those questions?
No. I can see. Don't worry.
Yeah, Q&A, there are 4 questions.
So I know the participants here, they do have so many questions perhaps in mind, but don't worry. Perhaps I can give you also my email. You do have my email. Ask me, write me email. I'll elaborate with all of the questions here. But let me start with this, Dr. Bohoyan. So how does GeoIME take into account the fact that building integrity reduces over time? Do you refeed manual survey data into the model? I'm not sure that whether I understand your question or not, but if you mean the temporal changes, right? Definitely, yes. You do need to go to the field and collect some data. But mostly, if you have your cadastral map updated, and, upload it in your system, right? So you don't need to go to the field there because already it is done. Unless there is some really necessary to go there. The changes could be also seen by the satellite images and high resolution satellite images. And I would suggest rely on the cadastral map. Okay, so I forget to say that this technique, what I'm talking about, remember I said half day to 1 day, it needs to estimate and to calculate the building, right? To investigate, for a screener. And also how much money? $1,200 for 7,200 square feet. But here in this system, you reduce the cost to $300, for example, right? Time, almost 15 minutes, but in 10 to 15 minutes. Half day become 10 to 15 minutes, right? If you have some data. That's one of the limitation and also challenges at the beginning I said, privacy, data, and so on. If I ask Professor Kundu, would you give me data of your home? How is it possible? He may say no, So this is a government bodies. They have, the government should apply with this one. I'm not sure whether I really answer your question or not. Just thump if I answer your question. So how do you ensure quality of the input data? This is again the good question. The quality of data, number one, it comes from the government. I ask Professor Aggarwal or Kundu from the government body. How do you accurate your data is? How is the truthfulness of your data? So I rely on that. So that's why I collect the data from them. I'm not producing the data. I'm not producing any extra data. Number one, I use those maps. The accuracy and the quality, it comes based on the Google, the resolution of the Google, for example, if you use satellite images. The accuracy of the soil type, if you could see the soil type with the velocity, right? So the accuracy comes with the USGS. Do you believe accuracy of the USGS or not? If yes, then it's a false solve. If not, then this is another question. But always the truthfulness of data, and also accuracy is a big challenge. It's a big challenge. And also integration of them. How reliable are the manual survey records or building plan chart? It's again a good question. As I told you, this is, if you go to the survey, what happened is that because rapid visual screening and expert knowledge are different. So if I ask Professor Kundu, okay, tell me about, for example, your visualization of that particular building. If I go there, might be two things different, right? So in that regard, the system does not allow you to do that then. So take an image, send it to the system will understand the differences between two actually expert knowledge. So does the model carry out some kind of validation? Yes, we did that one actually. We already did the validation based on ground truth visualization. So we have about 1,000 buildings. So for all building, we went to the field and test with the system. That's we come with the validation and performance of the system. The system does not actually, I would say, much. It's not a question the system accurate or not, the performance of it. Is the system it is the question of how FEMA is accurate, because we didn't do anything. We just integrate the system to system. We create ecosystem. We use APIs. Yeah, we use Esri. So how do the Esri come with? So these are the things we have to understand for the validation. So going to the next question again from Bohayan, what is limitation exist for the GeoIME as far as organizational is concerned? I told you, I think during the presentation I mentioned, one of them is privacy. right? If I ask Boyan, would you give me the information? I don't know whether really or not, unless the government comes in. The accuracy also is the one, again, you said, right? Whether the people, they allow you to go to the house or not to understand, to calculate or not. There are some other satellite image processing. These are the limitations we are challenging actually with. Mostly the big challenge, I would say, from my experience, is that data sharing and privacy. It's very important. And going to Janita question. Hello, sir. The output maps are being produced at what scale? Good question. The scale, it depends on the resolution of your satellite image and the resolution of what your digitization. At the end of the presentation, I try to digit, right? So the digitization is based on that. The scale is based on that digitization resolution of the image. Number one. Number two, again, if you have the what do you call the map, the cadastral map. So what is the cadastral map scale? 1:500? What in your country? So the scale would be like that. I hope I answered your question. If yes, please, Tom Price. So can this can this application be used for potential building collapse due to shrinking winds? Yes, I do. Yes, we can. Rainfalls. As I told you, this is ecosystem. What does mean is that if you do have from here, flood, you do have a storm, you do have earthquake, you do have landslides. From that side, you do have breach, you do have building, and so on. So the APIs and the platform framework, I would say architecture, design has been made in such a way that would be customized, would be able to customize. If I give you, then you can customize it actually based on your, but let's say, for example, for the rainfall, the main question is that, do you have the instruction code of flood? If yes, then possible. If not, no, it's not possible. So going, I hope I answered your question. Please, Tom, raise your hand. So my question, Soban. Oh, my son is also Soban. Yeah, very good. Yeah, yeah. My question is, can this website app take care, or can it be tweaked or take care of natural disaster in different parts of it? Yes, as I told you, is it customizable, and also scalability is there. It's no problem. Contact me in future if you need anything. Just let me know. I think flood risk, desert, and this in South Africa. Perhaps I answered the question before, so it's the same answer, I think. So you can have your own instruction code. Remember, country to country is different. Okay, country to country is different. The instruction code of India is different with the US. But I understand that, for example, in Iran and India, sometimes they use also FEMA. If you use FEMA, then you can use it, right? In South Africa, they use FEMA, for example, right? It's possible in most of the countries. But if not, still you can customize. For example, for China, I did customize because they have their own local, actually, what do you call instruction code. So we did that one. So thank you. So going to Parasant Shahi. Oh, I like the name of Shah. Shah means king. So, sir, what type of predictive models were used in analysis for structural integrity testing? So we don't have right now any kind of predicting model. So we don't use AI or something like that. But we actually create some modules using image processing techniques, RCNN, okay, and also some other models from deep learning, but only for 1-2 features to extract. let's say, for example, for crack detection, then we use it. Yes, prediction, modeling, yes. Then in that case also, but not all building. Because as you could see, to understand the vulnerability of the building, there are some parameters, right? So we cannot do all, but at least for now. But in future, now we are working. That's why I'm thinking of GeoAI. So at least you can have some prediction then, right? So going to next question, Dr. Parkash. How does GeoIME integrate different geospatial data sets, such as remote sensing, LiDAR? And it depends on your data, actually. If you can have if you could see the GIS layer, so they are different layers, so you can put the data over there. But it depends on your project. What type of project do you want to do, right? If you want to do earthquake, then you should have some instruction based on those. You have to highlight those layers. So most, for example, in that case, why should I use, let's say, flood data? Why don't use it? It doesn't matter for me for earthquake, right? Or for, let's say, for example, rainfalls. I don't use it. Why should I use it? Lithology. Here I use it because there is a soil type, right? And some other may not. So, but if you use LiDAR point cloud, perhaps one of the other limitations, I would say, it's a good question. I remember now, as the data, if you put it the point cloud, it takes a long time to upload. This is all depend on the cloud. And also, if you put, for example, grid, again, but mostly we use vectors. Anyway, so now going to, okay, that's all, I think, all questions. And one thing more, I should be very thankful to India because I did my first PhD in India. I love India. Thank you.
Yeah.
Thank you very much, Professor. Sir, will you like to say anything, sir? Aggarwal, sir?
No, I'm really thrilled to hear Professor Saeed. Wonderful lecture. The way very nicely you started. Professor, you are really excellent, Professor. That much I can tell you. Fantastic lecture, starting with very simple ideas, and it is culminating into a solution of such kind of problems which entire world is facing. Really, I'm hats up to you, Professor, and thank you from core of my heart. I would like to thank you for your nice presentation, giving your time and deliberation. Very nice. Thank you very much.
Thank you very much, Professor Aggarwal. I know you for a long time,
Yeah.
But I never
Yeah.
see you. I never see you in person. Hopefully, in Dubai, I can see you.
Yes.
Yeah, appreciate you, and thanks to every participant. I really appreciate all of you. Without you, perhaps I would not be able to have energy to do that. And this,
Yeah, you are having lot of claps. You can see, people are.
thank you very much. And giving me this opportunity to contribute to ISPRS and knowledge of the people. Really appreciate you. Thank you.
Thank you.
Yeah, sir. I also, on behalf of ISRS, ISPRS Working Group 54 and NISAC, I also very sincerely thank you, sir, for this informative and important talk. And you have covered very nicely the ways of increasing resilience in infrastructure from various disasters and how the geospatial technology can be used for this. This is very important for our region because we live in a seismic 5 zone. Not only that, a very strong flood, lightning, landslide, every kind of disaster is there in this zone. So whatever you have taught, I think it is very well taken by your team here. Thank you very much for sparing your valuable time, and I look forward that we'll be having you again sometime in near future.
Thank you very much. Thank you.
And I also thank Chair of ISPRS TC 54 and President of ISRS, Dr. S.P. Aggarwal sir, for his continued guidance and support towards planning this webinar. And I also thank Lakshmi for his continued support for the webinar advertisement and hosting the platform, hosting it in Zoom. and look forward to this support again. And finally, I thank all the participants. There has been a very active good number of participants from across the countries. I could see that there are participants from Ghana, Nepal, Philippines, Nigeria, Mali, New Guinea, Papua New Guinea, Italy, of course, India. So it has truly been a global presence today. And I'd like to inform you that the next lecture in this series is scheduled on 11th March at 10 UTC. Which will be delivered by Dr. S.P. Aggarwal, sir, President of ISRS. And this will be on understanding disaster risk and geospatial technology for effective DRR, the India experience. So hope to see you all there as well. Thank you all. Have a good day.
Thank you. Bye-bye. Bye-bye.
Yes.